Hello students, this is the continuation of our previous video lecture. Now here we have problem 7. The question is to find the Laplace transform of cos hat sin at. Now how to solve this problem? Now if you see, this is a product of two functions. So we have to apply the theorems on Laplace transform. But we should know what theorem we have to apply. For that, first if you see, this is cos hat and this is sin at. We do not have trigonometric formulas in product of these two, but we can recollect that we have the hyperbolic formula in terms of exponential. So by using that, we can rewrite this cos hat. So what is the formula? So the formula that we will be using here is, we know that cos hat is equal to e to the power at plus e to the power negative at divided by 2. So this formula we are going to make use of it over here. So first let me write these two terms alone, so that cos hat multiplied with sin at can be written as, now let me substitute this. So it will be e to the power at plus e to the power negative at divided by 2. So this has to be multiplied with sin at. Now if we multiply each of the terms, it will be 1 by 2 can be taken as common, and we will be having e to the power at multiplied with sin at. So e to the power at sin at plus e to the power negative at has to be multiplied with this. So e to the power negative at sin at. So this is what we obtain. Now we have to take the Laplace transform of this term. So the Laplace transform of cos hat and sin at will be equal to the Laplace transform of this complete term that we have obtained. 1 by 2 constant can be retained out. So 1 by 2 multiplied with Laplace transform of each of the terms separately can be taken by using the linearity property. So Laplace transform of the first term, that is e to the power at multiplied with sin at, plus the Laplace transform of the second term. So it will be e to the power negative at sin at. Let us mark this as equation 1, so that we will find the Laplace transform of the first term separately and the Laplace transform of the second term separately, and take the answers and substitute over here. So let us do that now. So first let us find the Laplace transform of the first term, that is e to the power at sin at. Now here we have product of two functions where one of the function is exponential. So what theorem we have to apply here? If you have followed my previous video lectures, you will know that we have to apply the first shifting theorem. So when we apply the first shifting theorem, this will be equal to, we have to find the Laplace transform of the function f of t. So f of t is what here? Sin at. So Laplace transform of sin at, and in the resulting answer we have to shift s to, here we have e to the power at, so plus here. So we have to shift s to s minus a, that is we have to replace s by s minus a in the resulting answer of Laplace transform of sin at. But by the formula of Laplace transform of sin at, we know that it is equal to a divided by s square plus a square. So this is the answer for this. So in this we have to replace s by s minus a, which is equal to, so after replacement you can remove the flower brackets. So a divided by, now here we have s square, so it has to be replaced as s minus a square. So s minus a the whole square plus a square. In a similar way, we have to find the Laplace transform of the second term. What is the second term? It is e power minus at sin at. So it will be e to the power minus at sine at, which is equal to, now here what is f of t? Sine at. So it will be, we have to find the Laplace transform of sine at, and in that we have to replace s by, now here we have e to the power minus a. So if it is minus a, we have to replace it by s plus a by using the first shifting theorem. Now what is L of a sine at? We know that it is equal to a divided by s square plus a square. So in this we have to replace s by s plus a. So therefore this will be equal to a divided by s plus a the whole square plus a square. So now we have obtained the first and the second term from equation 1. That is, in this we have obtained both of these. Now we can take and substitute this and conclude our problem. So after substitution, what we get is, so therefore this is what we obtain. Now in this we can take the a common from the numerator and it can be written as a by 2 multiplied with the remaining terms. So this is the solution of the problem 7. Now let us do problem 8, which is the same as problem 7. So now here we have problem 8, which I have already solved for you. You can quickly have a revision of it. That is, so here we have to find Laplace transform of cos ht sin 2t. So first we shall consider cos ht and sin 2t. So that we have taken and written here. We know by formula that cos ht is equal to e to the power t plus e to the power negative t divided by 2. So we are taking this and substituting here and multiplying to each of the terms. 1 by 2 is taken common, e to the power t sin 2t plus e to the power negative t sin 2t. And then we are taking Laplace transform of this. So Laplace transform of cos ht sin 2t will be equal to the Laplace transform of this term completely. So we have taken 1 by 2 constant outside and we have taken the Laplace transform of each of the terms. And we have marked this as equation 1 like in the previous sum. And we are finding the Laplace transform of each of the terms separately. The Laplace transform of the first term is written here, which is equal to the Laplace transform of f of t, where s has to be replaced by s minus 1, because here we have e to the power t, that is we have plus 1 as the coefficient of t. So s has to be replaced as s minus 1. And we know that Laplace transform of sin 2t is 2 divided by s square plus 2 square. 2 square is 4, so I have written 4 here. In this we have to replace s by s minus 1. So here we have s, so it is replaced by s minus 1 the whole square plus 4. In a similar way, the other term is also found to be 2 divided by s plus 1 the whole square plus 4. And so we are taking these two and substituting in equation 1 and we obtain this. We find that 2 is common in the numerator, which can be taken out, but it gets cancelled with the 2 in the denominator. And finally we are left out with 1 by s minus 1 the whole square plus 4 plus 1 by s plus 1 the whole square plus 4. So this is the solution of problem 8. Hope you have understood both the problem 7 and problem 8. In our next video lecture, we will learn problem 9 and 10. Thank you.